Welcome to lesson 10.4 for pre-calculus. So today we're going to finish up all of our conic sections and we're going to end that with hyperbolas. So what exactly is a hyperbola? Well, by definition, a hyperbola is the set of all points, x, y, in a plane, the difference of whose distances from two distinct fixed points called foci is a positive constant. All right, well that doesn't really quite tell us what a hyperbola looks like, but that's what its definition is. So we're going to pull up a ton of more information here. I'm going to walk through it all with you. So first and foremost, we've got our equations. We have two different equations for hyperbolas. The first one right here, this is if you have a horizontal transverse axis, and I'm going to go into what that transverse axis is in just a second. And this second one here is when you have a vertical transverse axis. So you can see the difference between these two equations is simply the numerator gets flip-flopped. So on a horizontal parabola, your x is going to come first, and then you're going to subtract off the y portion of that. A squared is always first in a hyperbola. And then if we go into the vertical equation, our y component is the first part of the fraction in your numerator, and then you're subtracting off the x component of your hyperbola. So the biggest difference between a hyperbola and an ellipse is you've got the minus sign right here. And then secondly, you're going to know whether or not it's horizontal or vertical based on which comes first. If x comes first, it's horizontal, or I should say if x is positive, the x fraction is positive, it's horizontal. And if the y fraction is positive, then it's vertical. So now let's go over here and figure out what all of this is. So the transverse axis, that's what I was talking about as far as horizontal or vertical. The transverse axis is going to be the segment that the vertices lie on, and in fact they are the endpoints. So for this example right here, I'm going to change my color of my ink. Our transverse axis would be this segment right here that goes from one vertex to the other. That is your transverse axis. The center is going to be the midpoint of that transverse axis. So your center of your hyperbola actually doesn't lie on the drawing itself. It's going to be the midpoint of your transverse axis. And that center is h, k. We also have the equation c squared equals a squared plus b squared, just like we did in an ellipse. And you're going to be able to figure out your a squared and your b squared and c from this equation. So this will help you with figuring out where your vertices lie as well as where your foci lie. So the vertices are going to be a units from the center. So you will always have it be a units away. So if we were to write or find out this distance right here to this vertex from our center, it would have a distance of a. And same thing here, from our center to this vertex would also have a distance of a units. And as far as your coordinates for your vertices, if you have a horizontal transverse axis, and that's what we have on this graph here, then your vertices are going to be h plus or minus a, k. So for example, let's say that we know our center here is 0, and let's say that a equals 3. Then our vertices were going to be h, which is 0, plus or minus a, which is 3, k, which was also 0. So we would know that our vertices are going to be plus or minus 3, 0. Your foci are very similar, but they're c units away from the center. So your foci are going to be c units away from your center. In general, it'll be h plus or minus c, k for a horizontal hyperbola, and h, k plus or minus c. So one thing to note here, these are very similar to an ellipse as far as the equation goes, but we have a couple of key pieces of information that are different. One is that you've got a negative sign here instead of a positive, so you're subtracting the two fractions instead of adding them. And c squared is the sum of a squared plus b squared, whereas in the ellipse it was the difference. It was a squared minus b squared. So those are your two main differences with hyperbolas and ellipses. Okay, so now let's move on to the next slide. one thing that we did not go over on the previous slide was asymptotes. It was those red lines that were drawn in the graph. The asymptotes are actually there to help you graph the hyperbola. An asymptote is going to be where the hyperbola gets close to but doesn't actually touch. And so there's two different equations to find asymptotes. We've got them written down here. So you're going to do this equation right here, y equals k plus or minus b over a times x minus h. And this is going to be for your horizontal transverse axis. So this is for the horizontal one. Now we also have the equation y equals k plus or minus a divided by b. So the difference between these two is your a and b. So a divided by b over or times x minus h. So this will be for your vertical asymptote if you have a vertical transverse axis. And those are going to be these dotted lines right here. So here we've got the horizontal hyperbola because our transverse axis, we can see our vertices lie on a horizontal line. So this is horizontal. So we've got b over ax and negative b over ax. So it's the first equation that we use. Here is a vertical transverse axis. If we were to draw the line between our two vertices, it would be a vertical line. And we've got negative a over bx and y equals a over bx. So these are these lines right here. And they're just there, like I said, to help you sketch for a hyperbola when you sketch the graph. Okay, so that is it for the hyperbola. That's all the pieces of information that you need to know. Okay, so we're going to finish up with this example where we need to find the center, the vertices, the foci, and the equations of the asymptotes, as well as sketch the graph. So we need to get this equation into standard form. And we know that it's going to be x squared first because it's our y term that's negative. So let's go ahead and complete the square and get this to where we can get this into a standard form. So group like terms, we only have one term that has an x in it, so that's just going to stay. Now I'm going to group my other terms, so we have 9y squared plus 36y, and we're going to move the 72 over to the other side. Okay, so now I'm going to factor out a 9 because we don't want a negative 9. We do not want to have a coefficient in front of our y squared term. So now we have x squared minus 9 times y squared minus 4y equals 72. And we want to complete the square here. So remember, when we complete the square, we take the term in front of the y and divide it in half. So negative 4 divided by 2 equals negative 2. And now we're going to square that, and we're going to get a 4. So we are adding 4 inside our parentheses. But actually, we're really subtracting off 36. So we need to subtract off 36 over here. And we're subtracting because it's a negative 9 that we're going to multiply this 4 that we just added inside of our parentheses. So now let's simplify. We've got x squared minus 9 times y minus 2 squared, because we just completed the square, equals 36. Okay, so now let's go ahead and divide everything by 36 because we know that we want this to be a 1 on our right-hand side. So when we rewrite and simplify, we've got x squared over 36 minus y minus 2 squared over 4 equals 1. Okay, so now we've got it in standard form, so we can now find out all the critical pieces of information. So first, the easy one to get out of the way is our center. Our center is going to be 0, 2. And now let's identify what A, B, and C are. So A equals the square root of 36, which is 6. B equals B equals the square root of 4, which is 2. And C equals the square root of 36 plus 4, which is the square root of 40. Or we can say that equals 2 square root of 10. Okay, so we know this is a horizontal hyperbola, horizontal transverse axis, so everything's going to be happening to our x-axis. So our vertices are going to be plus or minus 6, so 0 plus or minus 6, which is just plus or minus 6, comma 2. And our foci are going to equal 0 plus or minus 2 root 10, so we're just going to end up with plus or minus 2 square root 10, comma 2. The last thing that we need to figure out is our asymptotes. So we're going to take our formula, which is k plus or minus, and because this is a horizontal one, it'll be b over a times x minus h, which is 0. So our asymptotes, and we're going to go up here on the top of the graph because I kind of ran out of room. So we have y equals 2 plus or minus b over a, so it's going to be 2 over 6 times x minus 0, so just times x. And this simplifies to 2 plus or minus 1/3 x. So now we're going to rewrite this where it's kind of in a y equals mx plus b format. So we have y equals plus or minus 1/3 x plus 2. So now we want to graph this. First, let's plot our center. So we know our center is at 0, 2. So here is our center right here. We know the vertices are at plus or minus 6, 2. So 1, 2, 3, 4, 5, 6. So we go positive 6, 2, and negative 6, 2. So 1, 2, 3, 4, 5, 6. The foci are at plus or minus 2 square root 10, 2. And let's figure out closer to what that number is. So 2 square root 10 is about 6.3. So we're doing plus or minus 6.3. So the foci are going to be just a little bit beyond here. So there's our foci, focal point, and here's another focus. Okay, so we have the critical points graphed. The asymptotes now are what's going to help us. So we know that we want a positive 1/3 slope for one of them. So that means we're going up 1 over 3, and then up 1, so it would be kind of here, then up 1 over 3. So it's going to be the line that looks kind of like this. And when you draw your asymptotes, it's a good habit to draw them as dotted lines, because then you know that they are asymptotes and not actual lines. So there's one asymptote. The other one's going to be a negative slope. So we're going to go over 1, up 1, and over 3 in this direction. And so on and so forth. So it's going to be the line that looks something like this. So that helps us with our hyperbola. So we know that our vertex is right here. So when we graph our hyperbola, we're going to draw it so that it is approaching the asymptote but not quite touching it, and it goes through the vertex. So there's our one of our hyperbola, and then our other one would be like this. And we're done. We have graphed everything. We found all of the critical points. So that's it for today. I hope you guys have a wonderful day. Bye-bye.